All right, let's get right into it. We're going to talk about a huge, expensive headache for anyone building AI. How do you build a system that doesn't just shatter the second the world changes around it? We're talking about AI that can actually fix itself when things go wrong.
You know this feeling, right? That horrible jolt in the middle of the night? Your phone is buzzing off the hook. It's not a test. Your most important AI agent, the one that's supposed to be making you money while you sleep, has just gone completely silent.
So, before you've even managed to find your glasses, the damage is already piling up. This isn't just some technical hiccup. This is a serious financial bleed. And that's the brutal math of the situation. Just 6 hours of downtime has already cost the company $60,000 in lost revenue. The clock is ticking, and every single minute is costing more and more money. So, what in the world caused this expensive middle-of-the-night disaster? Let's pull back the curtain on this 3 a.m. nightmare. And you can see how it just snowballed. It started with the downtime and the lost cash, sure, but then it got worse. It turned into an emergency weekend deployment, which meant frantically refactoring over 200 lines of code. And of course, the final price. One very, very angry VP. We've all been there. And here's the hard truth, the real problem here. We call it AI, but in this case, it wasn't being intelligent at all. It was just a fragile little script, following a rigid set of instructions that was basically guaranteed to fail sooner or later. Yeah, this wasn't some freak accident. It's actually a deep, fundamental flaw in how we often build these agents. We're essentially building ticking time bombs without even realizing it. The whole problem is right here, in how simple this connection is. The agent's code is basically handcuffed directly to the database. It is hard-coded to look for one thing, and one thing only, a column with the exact name price. There's absolutely zero room for error. And then, something totally normal happens. Just a routine change. A database admin, maybe they're just following a new company policy, renames that price column to cost_amped. This happens all the time. But for our fragile little agent, this is a death sentence. And boom, this is the result. The agent sends its request, asks for the price column like it always does, and the database just says, "Sorry, I have no idea what you're talking about." The system comes to a screeching halt, a total catastrophic crash. And if you think this is some rare, once-in-a-lifetime problem, think again. This kind of failure is triggered constantly by totally normal business stuff. Migrating a database, merging two company systems, trying to work with some ancient legacy platform, your agent is living on borrowed time. Okay, enough doom and gloom. How do we actually fix this? Well, we need to stop building brittle systems and start building something bulletproof. And the way we do that is with something called a semantic layer. Okay, look at this. It's the whole idea in one picture. On the left, you've got the old brittle way. The agent is chained directly to the database columns. But look at the right. This is the game changer. We've put a buffer in the middle, a kind of translator called an ontology. It sits between the agent and the database, and believe me, it changes everything. This is the big mental shift we have to make. We need to teach our AI to stop caring about specific names, like price, and start thinking about the meaning, the actual concept of what a price is. So, how does this magic actually work? The easiest way to think about it is that this new layer, this ontology, is like a universal translator for your data. So, the heart of our translator is what we call a canonical concept. In this case, let's call it hasCost. This is our one unchanging single source of truth that just means the price of an item. From this point forward, our agent only has to know this one single concept. Its job just got way simpler. Now, here's where the translator really shines. Our ontology knows that our one perfect concept, hasCost, can show up in all these different disguises in the actual database. It might be called price, or cost_amt, or even promo_price. The ontology keeps a list, mapping all these different names back to our one true concept. And that's the beauty of it. The agent gets to live in this simple, clean little world where it only needs to know one name. And the ontology does all the messy work of keeping track of the complicated, ever-changing reality of the database. It's a brilliant division of labor, right? Okay, but that all sounds great in theory. Does it actually work? Well, talk is cheap. Let's see the proof. All right, scenario 1. This is our baseline. The database has the original column names, price, and is_vegetarian. We run our agent, and just as you'd expect, it works perfectly. It finds the right pizzas with the right prices. So far, so good. Now for the magic trick. Look, the database admin has gone and renamed the columns to cost_amped and is_veg. In the old world, this is where we'd get that 3AN page. But now, with our semantic layer, we run the exact same agent code, no changes at all, and look at that. The output is identical. The agent has no idea anything even changed.
And this, right here, is the big win. We had to change 0 lines of code in our agent. We had 0 downtime, and we spent 0 time on a frantic weekend refactor. The system just healed itself. It worked because we designed it to be resilient from the very beginning.
So what's the big takeaway here? It all comes down to this simple idea, a new mantra for anyone building smart systems. You have to teach your AI to query the meaning of the data, not just the hard-coded names. And that's really the question I want to leave you with. Take a good, hard look at the systems that you're building. Are they genuinely intelligent? Can they adapt when the world inevitably changes? Or are they just fragile scripts, one simple database tweak away from becoming your next 3 a.m. nightmare?